Hello, myself Muhammad Thajuddeen. So today I am going to explain a small topic in the book BIOPHYSICS written by M.V. Volkenstien. So in this chapter 15.4 there is a AUTOCATALYTIC systems. So I am going to explain this chapter. So the Lokta chemical AUTOCATALYTIC system considered above is an oscillatory system. It is characterized by a singular point of a center type. Let us now discuss more complex point AUTOCATALYTIC chemical systems. We shall consider so-called Bruselator, the Progogine-Lefebvre-Nicolis model. So we have a four coupled reactions. A becomes X, 2X plus Y becomes 3X, B plus X becomes D plus Y, X becomes E. So in this all, there is a catalytics like K1, K2, K3 and K4. So overall reaction is A plus B becomes D plus E. The reaction 2, which is 2X plus Y becomes 3X, is AUTOCATALYTIC. So the kinetic equations for the intermediate compounds like X and Y are as follows. X is equal to K1A plus K2X square Y minus K3Bx minus K4X, where Y is equal to minus K2X square Y plus K3Bx. We introduce dimensionless variables, that is gamma is equal to K4 into T, where A alpha is equal to A into K1 by K4. So analogous equations are obtained at K1 equal to K2 equal to K3 equal to K4 equal to 1 at gamma is equal to T. We find the steady state solution by equating the left hand sides of equations 15.45 to the 0. From the second equation we find that x naught square by y naught is equal to b into x naught. Substituting into first equation we obtain x naught is equal to a and hence y naught is equal to b by a. So the solution is only one. We study its stability. We seek equations from the 15.5 in this form. In considering the point and distributed Bruselators, we neglected the reverse reactions and thereby moved far away from the equilibrium. The spatial structure depicted in the figure stabilized by the flux of energy and matter passing through an open system. This distributive structure is characterized by the lower entropy than the original homogeneous system. A phenomenon called order through fluctuations is realized. Of course, the real system is not a homogeneous system with constant boundary and conditions. The concentration themselves, A and B, that appear in the parameters depend on gamma and T. So for AUTOCATALYTIC systems, we need a solution. So the properties of solutions are, one is near equilibrium, there is only one stable steady state. And second one is the far from the equilibrium, various situations may arise. In region 2 of diagram, the thermodynamic branch becomes unstable with respect to fluctuations in chemical compositions. Beyond the threshold of B, initial deviations from the steady state become larger and eventually bring the system to a new steady state corresponding to the non-uniform distributions of X and Y. And the fourth properties of the solution are, the thermodynamic branch is unstable and the system passes over the spatially homogeneous time-dependent state. And the fifth one is, at finite values, the structure described are localized inside the reaction volume. So that's all. Thank you.